Hey, and welcome back to Hands-on Problem Solving with Machine Learning. In this section, we're going to talk about logistic regression and how we can classify flowers using this technique. In this video, we're exploring and cleaning the plant's datasets. Let's take a look. So this section is about logistic regression, and I'm in my Jupyter notebook, and again, I've navigated to my chapter 4 for you guys, and so what's happening here is we want to explore the problem of predicting labels. So what that means is we are trying to label a data point or many data points into one of many labels, right? So what kind of problems of this nature? So for example, you might want to have a collection of photographs and you want to label who is in that photograph, right? So there's no middle ground between your friend John and your friend Mary. Whereas in contrast to logistic regression or classification, you have regression, which is the prediction of a number. And in a number, you can predict, let's say you're looking at today's newspaper and you want to predict where the stock market is. You can predict 4,000 or 5,000 or any number in between, and there isn't really strict boundary between the different things you can predict. Whereas in classification, in this case, we're predicting different types of flowers. There's no middle ground. There's no middle ground between flower type A, flower type B, and flower type C. So classification has its own little characteristics because of this nature. The first thing that any good machine learning project is about is to explore and clean the data. So we have looked at a few topics surrounding this in the last few videos, and so I'm going to focus in this video the iris datasets, the iris flower datasets, and give you really a walkthrough of how we can perform this data cleaning and exploration process, just the iris example so that you get a feeling of how it all goes down. In 3, what we're doing here is we are importing the load iris function from the scikit-learn package datasets. So what this is scikit-learn has a lot of convenient functions for you to import different sorts of data into your shell, and that's a good way for sklearn itself to demonstrate its capabilities on its documentation on a unified dataset. And at the same time, it's very convenient for us because there's no need for me to send you any datasets or try to get you to download something that's humongous. A lot of these datasets are quite small, they are quite well researched, and it's a good base to jump off of. So that's in 3. In 4, we invoke the load iris function and we pipe the resulting data into iris data. Very conveniently, in each dataset, we can have a DSCR, description attribute of the data. So we can just print this description out and it gives us a few pieces of information. So number 1, it tells us that there are 150 instances in the iris dataset and there's 50 of each in each class. There are 4 attributes of this dataset, so there are 4 numeric predictive attributes, and these attributes are all in centimeters. And we have 3 classes of irises or flowers, which is setosa, versicolor, and virginica. One of the things that you can see is, for example, the correlation between petal width and petal length is quite correlated. So we will see later on how we defend ourselves against that issue. As always, in 6, what we're doing here is we are putting the data, i.e. the predictive variables, the 4 predictive variables of the iris datasets into X, capital X, and that's because capital X is conventionally used as a variable to store the predictive variables. So that's in 6. In 7, we're simply printing out the values of x, and I find that that's a fairly good way for anybody to really get a hang of the data that they are dealing with. Otherwise, it's kind of like you don't really know what the data is, you don't really know what it looks like, you don't really know its characteristics, and you're just blindly applying functions to the data with no idea how you can visualize the impact of applying these transforms and predictions on your data. So I would say the first thing is always to look at what the data looks like on a row by row or even data point by data point basis, just to get a good feeling of what works, what might work, and what doesn't, right? So that's in 7. In 8, we bring in the big guns, so we bring in pandas to help us clean up some of the data. So here we're doing import pandas as PD. PD being a convention in the data science world where it saves on typing when you use various global functions of pandas. In 9, we create a data frame version of x, aptly called x_dataframe, and we'll equal this to a data frame version of x with the column names equals to the feature names of the iris data. In 10, we print this x_df out, and we can see that we have a very nice and tidy data frame that has the, I guess, semantic column names or feature names of x printed on top. So we notice a couple of things, right? So petal width seems to be varying between 0 and 0.5. Petal length varies between 1 to 2 and then more higher down here, so 1 to 7. This might indicate that petal length is a good discriminator of what is in different classes, whereas petal width seems fairly uniform across the top of the dataset and the bottom of the dataset. It's these things that you notice as you start looking at the data and brainstorming how exactly you want to create a predictor. We also want to see the target. So we can see that the target is actually quite ordered. So we have the first 50 of class 0 in this section, and then in the middle section is the second class, and then is the last class. So you can kind of even say like, oh, anything that has the third feature around 5, 4.5, 5 to 6 is probably class 2, whereas something that has the petal length around 1.5 is probably class 0, right? So this is where I mentioned the benefit. Like once you build up an idea in your head of how you might classify it, how you might learn this, it's much easier for you to create something that makes sense. So in 14, we create the flower type as a column to associate a target with all the 4 features. And again, this helps us really look at what might be good predictive variables. And so we can look at actually grouping by the flower type by calling the group by function and look at the minimum, the maximum, to get a sense of where the variables are bracketed. So here, if you look at sepal width, all the minimums are the same and all the maximums are similar, which might indicate that it's harder to get information out of sepal width. Whereas, for example, petal length is very tidy, right? So flower type 0 is 1 to 2, flower type 1 is 3 to 5, and flower type 2 is 4.5 to 7. So you can imagine that simply by petal length, you can probably tell between class 0 and class 1 and 2. And then obviously you can then use something else to predict or differentiate between 1 and 2, maybe a combination of petal length and petal width.